Continuing to continue 10.2 Cyclone Development and Movement. Moving on to extratropical cyclone development. Necessary conditions include a strong temperature gradient at the surface, usually along cold, warm, or stationary fronts, and strong upper level winds provided by the jet stream. The jet stream could be the polar jet stream or the subtropical jet stream, or even both. The jet streams are from about 160 to 310 miles wide and are several miles thick. They travel faster in the winter, about 110 miles per hour, and slow in the summer at about 55 miles per hour. The polar jet stream shifts from crossing the United States in the winter to crossing southern Canada in the summer. Further to the south, the subtropical jet stream crosses Mexico and Florida. Both jet streams are strongest in the winter. The map below has the relative positions of speed of the polar jet. The winter position and speed are indicated in blue and are further south. The summer position and speed are indicated in orange and are farther north. The jet stream shifts position due to shifts in temperature contrast between the poles and the equator at different seasons of the year. Large high-pressure ridges and low-pressure troughs cause jet streams to bend, producing waves or meanders. Extratropical cyclones often develop in curves or divergences in jet streams. So let's relate that statement to some weather. The cartoon shows the jet stream in a tan tire track like arrows flowing and bending over Western Europe. The cold polar air is labeled on the northern blue side of the jet. The warm tropical air is labeled on the pink southern side of the jet. And we've got high pressure ridges labeled south of the more northern portions of the jet, and a low pressure trough north of the more southern portions of the jet. Everything is overall moving from west to east, as indicated in the white arrow at the bottom. There is anticyclonic spin indicated with a red curved arrow at the northern hump of the jet, and cyclonic spin indicated with a blue curved arrow at the southern hump of the jet. So one more thing. There are two acronyms. NVA stands for negative vorticity advection and is marked in straight blue arrows. And PVA stands for positive vorticity advection and is marked in straight red arrows. You don't need to remember all the words, but you do need to remember this. Where there are the red arrows, the anticyclonic spin and the PVA, this is where warm, moist air from the surface ascends into colder air aloft, leading to you-know-what? Condensation, severe weather, storms, etc. Where there are the blue arrows, the cyclonic spin and the NVA, this is where cold, dry air descends, leading to just cold surface temperatures. Severe weather is very, very unlikely to occur here. So to review, the anticyclonic spin, indicated with a red curved arrow at the northern hump of the jet, and cyclonic spin, indicated with a blue curved arrow at the southern hump of the jet. So one more thing, there are two acronyms, NVA stands for negative vorticity advection and is marked in straight blue arrows, and PVA stands for positive vorticity advection and is marked in straight red arrows. You don't need to remember all the words, but you do need to remember this, where there are red arrows. The anticyclonic spin and the PVA, this is where warm, moist air from the surface ascends into the colder air aloft, leading to you know what? Condensation, severe weather, storms, etc. Where there are blue arrows, the cyclonic spin and the NVA, this is where cold, dry air descends, leading to just cold surface temperatures. Severe weather is very unlikely to occur here. Bending or splitting cause the polar jet stream to dip south and the subtropical jet stream to flow northeast. The southwardly dipping polar jet stream often brings some super cold and dry air with it, and the northward flowing subtropical jet often brings some warm and moist air with it. The jet stream may also split in two around isolated high pressures and reunite. The southern branch of a split polar jet stream in the Pacific Ocean brings warm, moist air out of the tropics, which West Coast forecasters refer to the flow of warm, moist air as the Pineapple Express because of its origin near Hawaii. The images to the right show the typical wintertime weather anomalies preceding heavy West Coast precipitation events. We start at the top, 7 to 10 days before the heavy West Coast precipitation event. The strong polar jet, marked in a thick blue arrow, has a big meander to the north around a high pressure zone. You may want to think of it as a meandering river. The flowing air doesn't want to go all the way to the north, so it first splits around the high pressure area, reuniting further to the east, as depicted in the middle image, 3 to 5 days before the heavy West Coast precipitation event. Finally, all the polar jet stream is diverted south of the high pressure, as depicted in the last bottom image. This southward movement of the polar jet, followed by the northward flow, drags heavy rain from the western, southern, and central Pacific all the way to the west coast of the United States, as depicted in the images by a dark gray cumulonimbus cloud with rain and a green moisture plume. You can see in the bottom image, rain extends from Hawaii, you can see the small orange dots, all the way to California. There you go. The Pineapple Express. Here is a weather map showing an actual heavy West Coast precipitation event that is sometimes called the Pineapple Express. The darker orange colors correspond to more intense precipitation. The same images from the preceding slide are also present for your reference. Take a pause to let your brain soak in all the information on the images. There is a lot to see. Nor'easters, another wonderful extratropical cyclone, form when bends of the polar and subtropical jet streams begin to merge off the southeastern coast of the United States, which is wonderfully depicted in the image below. We've got the two jet streams marked in yellow bands with black arrows. The polar jet is to the north, and the weaker subtropical jet is to the south. In the north, over Michigan, the image caption reads, "Arctic air plunges south as north branch of jet stream digs into the southeast." Cold, frigid air. To the west, there is cool but not frigid air between the two jet streams. In the south, we have warm, moist air associated with the weaker southern jet stream. That merges with northern jet to amplify the pattern. And then, importantly, we've got the low pressure prime area for storm development, indicated in red, and its pathway to the north, up the east coast, which will develop into a wonderfully horrible extratropical cyclone, commonly known as a nor'easter, that will pelt the megalopolises and close airports and wreak havoc for a few days. So over the next few slides, I will walk you through this image showing extratropical cyclone development. Take a moment of pause to look at the image, which is also found in your book. What do you see? In the beginning, a low pressure center develops along a fairly straight frontal boundary, picture A. Remember that the cold front is indicated by the blue teeth and the warm front is indicated by the red half circles. A wave in the boundary develops, picture B. A conveyor belt of cold air begins to circulate counterclockwise, picture B again. The warm air is wedged to the east, and the conveyor belt of warm air rises on the southeast side. The cold and warm front are very distinct now. A conveyor belt of dry air aloft feeds the cyclone from behind the cold front. Cyclonic circulation is established. All of this is seen in picture C. On to picture D. The conveyor belt of warm air continues to rise on the southeast side, creating a comma. The conveyor belt of cold, dry air aloft continues to feed the cyclone from behind the cold front. The occluded front begins to form, indicated in purple, as the cold front overtakes the warm front, forcing the lighter, warm air aloft. Picture E. The cold front continues to wrap around the warm front. The occluded front is well developed, warm air trapped aloft. The cyclonic motion of the extratropical cyclone is obvious. Finally, picture F. The cold air completely displaces the warm air. Pressure gradient weakens and storm dissipates. The cyclonic airflow weakens and dissipates. Is the air stable? Warm air is aloft, where it likes to be, and cold air is beneath, where it likes to be. We are back at the composite picture for the last concept, the storm track. The extratropical storm depicted develops as it travels from west to east with the prevailing winds and jet stream across the United States. Other storm tracks follow a similar pattern of storm development and dissipation, though the track may be in a different location, such as the Pineapple Express or a nor'easter. One more picture to help us get the 3D-ness of it all. Air is going up and down as well as side to side, so we've got a well-developed extratropical cyclone. Could have an occluded front by that low pressure center indicated with a large red L. So we have a cold front and a warm front. The cold front has cold air behind it, indicated with the yellow arrows on the bottom image, cold and dry. The air is descending from aloft, cold, dry air, not producing condensation, no clouds, no precipitation, creates a dry slot, as indicated on the top image. The warm front is warm air advancing into and rising above cooler air. It is indicated in red arrows on the top image and an orange arrow in the bottom image. Since the air is warm, it is also as moist as can be, and condensation forms as it rises over the cooler air, indicated in the bottom and top images by the blue arrows. The warm air aloft curves away from the occluded front, whereas the cool air at the surface curls both into and away from the occluded front. Here's the same slide with a real picture of an extratropical cyclone. On the real picture, can you identify the key features? Can you see the dry slot? Can you see the cold front? Can you see the warm front? Can you see the comma head near the occluded front and low pressure center? You can use the cartoons on the slide and the picture in your book to help out. Hopefully, you've got the basics of development and movement of cyclones down. And with a bit of review, you can explain it all to your friends and relatives and sound like an awesome smarty pants. And explain it to me on a test or something.